to introduce session 2 for the conference, which is entitled Organizational Design, Innovation, and Feasibility. And we have a series of 3 speakers. So we're going to start.
All right. Can you guys hear me okay? Okay, super. I was told to come here, so there is no loss in effect. So Thomas Lambot. I used to run the Hyperloop project. I was a lead engineer for the Hyperloop prototype that we built for the Hyperloop competition some years ago. Just disclaimer, I recently left the organization, but I'm speaking on behalf of the organization right now. So some background on rLoop. So 2015, there was the Hyperloop competition was announced. The idea, most of you guys are familiar with it. The SpaceX was going to build a 1-mile track in Hawthorne, and they invited teams from all around the world to come up with design ideas, and they're going to select the best one so they can build it and race it down the track. That's why most of you guys are here. At the same time, this announcement was made online. Someone posted a message on Reddit. And Reddit, for the people not familiar with it, it's kind of an online forum where people post news, pictures of cats, whatever you can find on the internet. So someone said, hey guys, how about we create a Reddit team? And a bunch of volunteers, so a bunch of people, strangers on the internet, started to reply and say, yeah, come in. I'm a mechanical engineer, I have some spare time. Or hey, I can do you guys a kick-ass website. And so basically we started to get organized. We had a spreadsheet and we said, okay, we should have a lead engineer, we should have someone in charge of business, we should have something for mechanical. And very quickly we created an organigram, and people online started to apply to it and say, hey, my name is Thomas, I'm an aerospace engineer. I think I'd be good for leading the group because of X, and people would vote on it. And so we organized, and rLoop was born. rLoop was standing in the beginning for Reddit Loop, but because we didn't want any issues with them, as we're not affiliated with them, we called that to rLoop, which is a bit more nicer, I'll say, more 60-something. So all of that, so what we had to do was to design a prototype, and none of us were sitting in the same room. We had people on every continent. We were fully open, so all we had was a bunch of tools that you can find pretty much freely online, including Slack and things like that. So we found ways to communicate. We use Slack, and people will come in Slack, and we had different channels. People will be discussing about different type of design. And we will be running an organization like any project is run. We were having tasks, we're having meetings, all of that entirely online. We're doing design also using tools such as Fusion 360, which allows you to do some CAD design without exchanging the files. So we put together a proposal to SpaceX in early 2016, sent that, and we were selected as the best known student team. We got like our first award there, back then when there was still a design weekend. The whole entire design was made entirely online without ever meeting in person. We never exchanged a single email for the whole build. We just, again, used the tools that were available online. So how were we structured? So very quickly, yes. So we, basically 2 big parts. There was a engineering part and non-engineering part. Non-engineering part was led by Brent Lassard, is over there. That was all the business stuff, so finances, website, partnership. And I was leading the engineering team and basically making sure that we were delivering a Hyperloop, a sane product at the end to bring to SpaceX. And all the teams had a lead, just a volunteer, and the lead was not the most, maybe not the most experienced person, but the person that had the best organization skills. And then the way it worked was the members, the different people working for the project, they were not bound to a team. Everybody could work on anything they wanted. That was very important. So, and the way we're doing that was basically you take a big project and then you divide it in a bunch of smaller parts. You identify, it's kind of system engineering. You identify all requirements, all the parts, and you break it down to the smallest part where it becomes just, you need to design a chair, you need to design, just someone needs to design some legs with those requirements. And the people from the crowd, they will just see all those tasks, say, oh, I think I can do that. And that's the way it was working. All the people were picking a task, doing it, and our role, the management role, was to put all those tasks were made, make sure that there was some quality insurance, put them together to create the final product. So the entire system, the entire thing was built like that. So let me talk to you a bit about the pod that we designed. So we call it the rPod. The whole idea behind the design was we were not really aiming for speed. We wanted a system that could contain a lot of subsystems that may be able to scale up for future Hyperloop vision. So we wanted to test as many systems as we could in something that makes sense to be scaled up. So we had the aeroshell. We had a pressurized compartment, a pretty large one, a large pressure compartment in which you had an electrical tray, which contains all the electronics, the batteries. And then you have what we call the substructure, which is a kind of a cradle with everything that was levitation, brakes, etc. So that was the concept you just saw, like a nice exploded view CAD. And that was the concept we had made online. We had to turn that concept into a reality. It's good to have a lot of people dream about something online and say, okay, we can do that. No, we actually need to make it happen. I like to say, 10% idea, 90% execution. So how are we going to do that when nobody's on the same time zone? What we did is, through some smart partnership, we found a space in the Silicon Valley in Menlo Park. And I happened to live nearby, so I said, we'll take that space, we'll take that lab space. We raised the Indiegogo, so a crowdfunding campaign. We raised around 100K, enough money to get us started, get off the ground. And what I did, I posted a message on Facebook and Reddit saying, hey guys, people of the Bay Area, San Francisco Bay Area, we have a design, we have some money, we have a space, we have an online kick-ass team of experts. We need hands and time from people in the Bay to come and join us to actually build the thing, and the guys online will be advising it. And surprisingly enough, that worked. We had a bunch of volunteers coming to me and saying, hey, I have some time this weekend, how can I help? And a bunch of people here, like Aaron, that's how they joined the project. And quickly we had to get organized. All of that was within the timeline for the SpaceX competition. So it had to be very fast. I think that's also something that is very important in the way we worked. It was that the reason we're successful of making something online is because it had to work. We didn't start from a brick and mortar organization and say, oh, how can we go online? No, we had to work if we wanted to pass the competition. So that's what we did. People came, some sponsorship there and there. We built a pod. So let me talk to you about some of the subsystems of the pod. Pressure vessel, that's a big thing here. We tried two approaches. The first one was using what is used in like a semi-monocoque approach for aircraft. The same kind of way we use the way it's done for the aircraft, like the Boeing and the Airbus. So the design was great. One thing we realized that when you rivet a lot of stuff, it needs to be really well put together. And that there were some issues in the way we manufacture it because, again, just volunteers in spare time doing it for the first time. That didn't work. There were some leak issues. We went with the heavy heater, just welded a big tube, a big pressure vessel, and that thing worked perfectly. The batteries, and we have a poster on the batteries that Aaron will be leading. So if you have more questions, go see him after. But very quickly, we realized that the battery off the shelf were not providing the specs we wanted. So we said, let's just make our own batteries. We bunch of cells from some Chinese manufacturer. We didn't trust the data, so we qualified all the cells ourselves, put all the packs together, developed our phase change material, and we created like two monsters of 76 volt, 450 amp batteries. You can see the rest of the electrical system here, some stepper motor, power nodes, a big brain, the flight control unit controlling the whole thing. And again, I'm going fairly fast for the sake of time, but feel free to come see us after. The bottom of it, why do we have big batteries? Because we're doing active levitation. We are using also the ArcSpax hover engine, so hullback arrays, rotating hullback arrays. That's the way we use that. You can see them on top here. We had 8 of those distributed throughout the pod. We had some brake system. I'm not going to talk about the brakes. It's going to be a presentation coming up later, just focused on the brakes. So the hover engine were the big thing around the whole thing. We wanted something that can levitate in place just because those things were available off the shelf, and we figured it would reduce the amount of time it will take us to develop the thing. That was the pod as built. You can see it on the side of the beast. This is a monster. You've seen the pod at the competition yesterday. This was a monster. This was a really complex system, 700-pound thing that was levitating. Brent, and myself in front of the pod. That was the day of the competition. By the way, that's the second time we ever met in person. Again, everything done online. And that was the part of one of the presentation. So let's see if this video works. Yes, there is some sound. So just imagine that thing making, it's like a crying sound, wee, very high pitch. And that's the first time the thing ever took off. So you can see the wheels at the back are going to be retracting, and we're going to see a view from the side. Or awesome cameraman is in here too. And you can see the wheels lifting off, and you have 8 of those things running full blast. And that's copper, and you can see the thing levitating. Very first time, and then the next 30 seconds is just us cheering and crying. So this is the conclusion of the presentation. So what we did, within a year and a half, we started from a bunch of guys online, created a team, raised some money, found a bunch of volunteers, put that together, and actually built something that managed to win 4 awards, including the Innovation Award at the first Hyperloop competition. We achieved a bunch of firsts. We were the first pressure vessel demonstrated at SpaceX, and also the first pod to levitate inside the vacuum chamber at SpaceX. It was also, as far as we know, the first complex engineering prototype that was entirely designed and built by the crowd. And on that, thank you for your time.
Thank you, Tom. That's such a cool example of distributed team work, and I love the video of the hovering. We have time for 1 or 2 questions.
Great question. So no, during the first competition, yes, the question was, where are you doing any type of propulsion? It's a long answer, but the short answer is no, we're not using directly propulsion. The reason for that was the first competition, it was, the emphasis was put on using a pusher that was provided by SpaceX. So they had kind of a beefed up Tesla powertrain dragster the idea was to push your pod at high speed. So we went with that, and that was the main propulsion system back then. All right.
So we could do one more question while the next speaker comes up. So what's next for rLoop? You know? So
the question was, what's next for rLoop? And as I mentioned, I left the organization, so I don't want to speculate on the future of rLoop. But Brent Lassard, where is Brent? I saw him earlier. So Brent is outside, unfortunately. But you see someone with a rLoop t-shirt, and Brent is the person to ask that question. So they have some stuff they're working on.